Good morning. In our previous session, we have discussed about construction and working of glass electrode. We have discussed what are ion selective electrodes and also the applications of ion selective electrodes. So one of the application of ion selective electrode is determination of pH of a solution using glass electrode. So some of the uses of glass electrode let us discuss. Used in pH measurement, analysis of food, cosmetics, environmental regulations, soil acidity. As discussed earlier, so determination of pH is very important. Earlier days, if the water, whether it is potable or not, we used to collect the water sample, send it to the laboratory, and later, by the time we get the result, is to take 15 to 20 days. But now, due to ion selective electrodes, we can test whether the water is potable or not within fraction of a minute. We can test the total alkalinity level, total hardness, fluoride, everything in a fraction of a minute, and report can be generated within few minutes. So this entire credit goes to glass electrode, invention of ion selective electrodes. So one such credit is for glass electrode. So glass electrode can be used to determine the pH of a solution. So pH plays a very major role, that is pH of water which can be consumed should be basic and not acidic. Acidic water is not good to health, whereas basic water is good to health. So you know that pH ranges from pH scale is between 0 to 14. So 0 to 14 means 0 to 7 is acidic pH, 7 to 14 is basic pH. So water pH should be greater than 7, it should be minimum 8, right? Let us see how to determine the pH using a glass electrode. So in earlier days, so before the glass electrode was invented, so how to determine the pH? So we used to take glass electrode, we used to take calcium electrode. The both electrodes used to be dipped in solution of unknown pH and connected to the voltmeter. Okay, and another part is a potentiometer, and you know that is a Wheatstone meter bridge. Earlier days we used to use Wheatstone meter bridge. We used to have a jockey. The jockey used to be moved on the Wheatstone meter bridge, and we used to note down the reading. So by measuring when it beeps, we used to note down the potential. By measuring the potential, we used to determine the pH of a solution. It's used to take lots and lots of time. Okay, by discovering the pH meter, this entire process, time consumption process, has reduced. So how to determine the pH? So we're going to take calcium electrode, which acts as a standard calcium electrode, which acts as a reference electrode. We take glass electrode, which acts as a indicator electrode. That is ion selective electrode, couple connected to the voltmeter, and dip these both electrodes in a solution of unknown pH, or solution whose pH has to be determined. So now, once it is dipped, what are we going to do? We're going to measure the potential even here also. So here the glass electrode, here the calcium electrode acts as the cathode and the glass electrode acts as the anode. Since the calcium electrode acts as the cathode, and the cathode reaction is the H plus ions undergoes reduction giving hydrogen gas. This is the construction part. Calcium electrode will act as cathode and glass electrode will act as anode. Both will be coupled, connected to voltmeter, dipped in a solution whose pH has to be determined. So now the above cell can also be represented as mercury Hg2Cl2 Cl minus, that is calcium electrode, which is dipped in unknown solution and coupled with glass electrode. So glass electrode can be represented as glass membrane. This is dipped in 0.1 molar HCl, and the internal reference electrode is AgCl Ag. So this is the representation of the above cell. Alright, so above cell, it consists of glass electrode and calcium electrode dipped in solution of unknown pH. As discussed earlier, the electrode reaction which occurs here is liberation of hydrogen at cathode. That is, H plus ions will get reduced at H plus ions will get reduced at cathode, that is H plus electron gives hydrogen. So now, how to calculate the glass pH? So how to calculate pH? So we know that E cell equals E cathode minus E anode. So we have measured the potential of the solution. We have not determined the pH, right? So how to measure? So now it is very simple. So E cathode, E cell equals E cathode minus E anode. So cathode is standard calomel electrode, anode is glass electrode. So we know that Eg, glass electrode potential, is given by Eg naught minus 0.0591 pH. So from this equation we get the pH. So it's supposed to determine the pH, right? So we're going to equate this entire term to pH. When we equate it to pH, what will happen? pH equals Eg naught plus E cell minus calomel electrode, standard calomel electrode. So Eg naught is constant. So Eg naught, what is Eg naught? Eg naught is sum of internal reference electrode potential, that is silver electrode potential, asymmetric potential, and K. So it is constant. Eg naught is constant. E cell is the electrode potential which we measure, and ESC is a standard calomel electrode. So here only E cell we are going to measure. The ESC calomel electrode potential is given. E naught G will also be given. When we substitute all these three things here and divide by 0.0591, we are going to determine the pH of the solution. So this is how pH used to be determined in earlier days, but now we have digital pH meter. Since digital pH meter is there, the determination of pH has become very easy. And using this, we are going to determine pK. So in the laboratory, we are going to take calomel electrode, couple it with ion selective electrode, glass electrode, determine pH, dip in the solution, that is acid, titrate it against NaOH, determine pH of the reaction, and determine the pK value of the acid. So by knowing the pH of the reaction, we can determine pKa. So pKa is inversely proportional to strength. So what is pKa? How to determine this? We are going to do in detail in our laboratory when we come to the lab. Thank you.